Okay, hello, we're recording. Hello everybody, and welcome to Logger Lite. Logger Lite. This is a software put out by Vernier, the Vernier company. They make a lot of scientific lab equipment, a lot of stuff for teachers, and it comes free. The software comes free with the GoTemp temperature probe by Vernier. A lot of you are probably familiar with it. It's very basic. They call it Logger Lite for a reason. It doesn't do a whole lot. It does a few things. You can obviously buy a ramped up version for more if you want to spend some money and get all the bells and whistles. But being on a budget, I'm going with the Logger Lite, and it's perfectly fine for lots of basic introductory lab experiments. So I've got the probe in my hand right now. You can see the temperature going up here. So let me show you a few of the features. Here's a graph that it'll when I start collecting my data, it'll graph it in real time. Here's the temperature of the probe on just a fake mercury thermometer. And here's a table that will show all my data points, time and temperature. I can, one of the things I can do is I can change my time interval. I think I have it set for half a second. I'll double check that as we go. So what I want to use this for is an experiment, a laboratory experiment on freezing point depression. I'll introduce that by talking about the oceans. Why don't the oceans freeze, or why do they freeze at the poles and not other places where it's obviously very cold, and they freeze differently than freshwater. I think most people know that, but they don't know why, and so we can study that. But getting to the data probe here, I'm going to show you how it works. I can start collecting my data, and you can see time and temperature coming by, and you can't see it, but I'm going to stick the probe in a bucket of ice water here right now. So I've put it in a bucket of ice water, and you can see what happens. The temperature drops. When I do a freezing point depression lab, the graph won't look exactly like this because my bucket here is very, very, very cold water, but it's not turning to ice. When I do a freezing point depression, I'll actually be freezing something, and there'll be a phase change, and so my graph will look a little bit different. But I think I can show a little bit how the probe and the software work with this demonstration. So you see over here, I've got my table, and it's collecting my data. Half second at a time. And over here's the temperature that it's reading. I'm down to 3.2 degrees Celsius. And I've been doing this a couple times, so my water's a little bit warmer than it was when I started. Most of my ice is melted. I was able to get it down to like 1 degree. I don't know if I'm going to get much below 2.5 degrees. Most of the ice is gone, just cold water. This is just a demonstration. So it'll go up to 3 minutes as I have it set now. It'd be 180 seconds, but I'll end it here and just show a few of the couple of the analysis tools here. So this curved line here, when this isn't a real good representation, but when I do a freezing point depression, I'll have a horizontal line turn into a vertical line, and I'll need to get an intersection. And this drawing tool, I have to drag it to make a straight line. And then I get the two lines drawn, and I'll get an intersect. So an intersect can give you a prediction of a true freezing point. It's kind of hard to explain here, but on a freezing point depression, you do something similar to this. And now with this tool, examine, I get this horizontal line that lets me examine any data point that I want along my graph. So here, if I set it at 50 seconds, on the 50-second line, if you look over to the left, no, that's not working. Maybe up at the top. Yeah. So there's this box here. If you look in this box, there's the time, and I'll set my horizontal line to 50, and you can see my temperature is 3.6 degrees at the 50-second mark. I can do the same thing over here, and I get a prediction. You can see down here that I get a data point where I intersected the two lines. And that will tell me that my temperature should be 7.6 degrees. That was up here. At that predicted intersection of the two lines. So that's one way to analyze the data. If you don't like the graph, here, let's get rid of this. I don't know how to get rid of it. If I don't like the graph, I can auto scale it, and it will enlarge it or reduce it to fit into the screen better so that you can look at it better. And that's about it for now.